In this video, I want to use value substitution to analyze these Roman numeral statements. And in the next video, I'm going to use algebra. But I don't mean to imply that these are separate, mutually exclusive strategies. For many test takers, the best option might be to pick numbers for some statements and to use value substitution for others. So I've organized it this way, with value substitution in one video and algebra in another, just for ease of navigation. In case you just want to figure out how you might be able to use algebra to attack Roman numeral 1, well, then you can go to the next video and skip ahead until I'm analyzing statement number 1. All right, but here we are using value substitution, and for Roman numeral questions, it becomes especially important, or I should say, when you're using value substitution, it becomes even more important than usual to pay close attention to the logic of the question, and that often shows up in Roman numeral statements. So here we're asked, which of the following statements must be true? So that, of course, is a critical word. We need a Roman numeral that is always true all of the time, as long as we satisfy the conditions in the stem. So if we're using value substitution, what does that mean? Well, value substitution is really just going to give us one example, right? So if I plug in some numbers here and I get a true statement, does that mean that this Roman numeral must be true? No, right? That's just a single example. Maybe we just got lucky with the numbers we picked. But what if we pick numbers and we plug them in here and we get something that's not true? Well, that definitively proves that Roman numeral 1 doesn't have to be true, so we can just get rid of Roman numeral 1, and we can get rid of anything for which we find one example of numbers that make that statement not true. So let's get a set of numbers, and actually let's just see what happens if we plug in one set, some easy set of numbers up here, and just see if we can eliminate anything. So let's get an easy set. We've got to get positive numbers, and we've got a less than b less than c. I don't know. Let's go as easy as possible. Let's say a is 1 and b is 2 and c is 3, and that satisfies. They're positive and they're in the right order. So let's see if we can make some progress with these statements. Roman numeral 1. 2 times a is greater than b plus c. So with our numbers, we get, what do we get? We get 2 times 1 greater than b plus c, greater than 2 plus 3, and that leads to 2 is greater than 5, and that is definitively not true. So does this mean anything? Well, we're looking for which of the following must be true, and now we found one set that makes Roman numeral 1 not true, and that means that this doesn't have to be true, so Roman numeral 1 is gone, and all the answer choices that include Roman numeral 1 are gone. A's gone, and D's gone. What about Roman numeral 2? Well, let's see what these numbers do. C minus A is greater than B minus A, so 3 minus 1 is greater than 2 minus 1, and that leads to 2 is greater than 1, and that is true. So what does this mean? Does this mean Roman numeral 2 has to be true? No, right? This is just one example. We actually haven't really learned anything, so we don't know that we have to keep Roman numeral 2 in the answer choices because we just have one example. So for a must be true, it's kind of better to find that counterexample than to find an example that agrees with the statement. So we have not learned anything. Let's keep going. Roman numeral 3, C over A is less than B over A. 3 over 1 is less than 2 over 1, and that leads to 3 is less than 2, and that is definitively not true, and that's the good one, right? We're looking for which of the following must be true, and we just proved that Roman numeral 3 doesn't have to be true because it didn't work with our numbers. So Roman numeral 3 is out. That means C is out and E is out, and that is really good because only one answer choice is left in the running, and we can just click it and get our points.